Welcome back, algebra friends. So the purpose of this second video is just to provide you with some more examples and make sure that you're on the right track. So you'll see here that I have already completed most of these. I just wanted to take specifically a look at number 9 because when I graph those, if you notice, the two inequality lines, they're parallel. And in equations, what do parallel lines mean? They mean they will never meet. But remember, we're not talking about where they meet. We're talking about all of that shaded area. So I'm going to go back here and take a look. So first of all, the first equation is actually the bottom one here. It started at -6 and went up 3/3. From this equation, it tells me that it's greater than. So it would be everything above that line. Okay. Now I've also graphed the second one that started at 2, had a 3, but if you notice here, it is less than. So it would be, let's say if we went this direction, it would be everything on the other side. So our solution set for this particular problem, where do they overlap? They actually overlap in between. So my solution set would be in the middle. That's a little different than what you looked at before. So be careful with those. When you have parallel lines, be careful with which direction they're going. The only way it would be no solution is if they never overlap, meaning one's going greater than, one's going less than. They're going opposite of each other. And then I want to take a look at something just a little different, something we hadn't done in class yet, and that's an application problem. I just want to look at a word problem quickly. So Sarah's pet store never has more than a combined total of 16 cats and dogs. Okay, we're talking cats and dogs. So I'm just going to say, well, that means that my X, that's going to be my cats, and my Y is going to be my dogs. Then I will set it up. Well, when I put them together, I get 16. So when I put them together, not just 16, never has more than 16. So when I add them together, they should always be less than or equal to 16, no more than, right? She can have 16, but she can also have less. She also never has more than 9 cats. Okay, never has more than 9 cats. She can have 9 cats, but never more than. So if I think about my cats as X, my cats are never more than, so they're always less than or equal to 9. So from here, I can create my graph using this information. I can graph these out and find what are some possible numbers of cats and dogs in her store. So the first thing I'm going to do again is I'm going to rewrite this into slope-intercept. So I'd subtract x from both sides. So this would be the same as y is less than or equal to -x plus 16. Now looking at your graph, remember the x was cats, the y was dogs. We already labeled those. And I'm going to start here. I start at 16. So 1, 2, 3, 4. Looks like here, I'm going to count that out again just to make sure. 1, 2, 3, 4, 5. I get the same spot. All right, and then my slope was down 1 over 1. I'm going to give myself a couple of dots there so I can make sure I make a really nice line. And it is equal to, so it'll be a solid line. I'm going to go ahead and line that up. It's important that you get these nice and straight. If not, the whole graph is going to be off. And so this is kind of tricky. So go ahead and draw your straight line. And then for your cats, it's less than 9. So I'm going to go to 9. 1, 2, 3, 4, 5, 6. Now that's an X, so that's a vux, so it's vertical. So I can draw myself a vertical line. Okay, now they're both less than, right? So if I was less than this line, I would be down here. If I was less than this line, I would be over here. So I know that anything in this area over here would be possible. And that's how you can use that. So I could pick, well, she could have 2 cats and 2 dogs. This is an option, 2, 2. Here's an option over here. I mean, there's several options. here that are available. So remember, it's all about finding that shaded area because we want a set of solutions. We want to know this entire area is our solution.